All right, so this is just kind of a basic overview of the normal curve. We're going to ignore the empirical rule because it's really just kind of a subset of the z-table, and everything you can do in empirical rule you can also do in the subsets. So to start with, I like to draw a normal curve because this is what we're working with. So we have something like this. Please excuse my horrible handwriting here. So here's a normal curve, and right here in the middle, oh, that was really bad. Right here in the middle, that's our mean. So we've got a couple of things that are going on here, a couple of measurements. The first one is we have a number line going along the bottom here. And by default, this is kind of an X number line. So right here, right in the middle, we have our mean. However, every normal curve is going to be different. So every normal curve is going to have a different mean. It's also going to have a different standard deviation, which we'll get to in a minute. And as such, finding the area between two different values, there's an infinite number of those because there's an infinite number of means, there's an infinite number of standard deviations. To make life easier, we're going to convert all our values on that number line to this other number line, which is our z number line. So just remember z equals, not our mean, equals our value, our x, minus the mean divided by our standard deviation. Now our z-scores, some of the nice things about it, one, it has a mean of 0, because if you figure I'm using my mean, then I'm going to have the mean minus the mean in my numerator, which is 0. And then the other attribute is its standard deviation is 1. So I can really interpret that z-score to mean how many standard deviations away from the mean am I. Over on, so right here 0, over here we have positive z-scores, and to the left we have negative z-scores. Now keep in mind any value on here. So let's say here, which is the same position as here. It doesn't matter what scale I'm in, I'm still in the same spot. So I like to think of it as this first number line, this is Fahrenheit, and the second number line is Celsius. And they have different numbers to describe the current temperature, but it's still the same temperature. So our first piece of information is that z-score, that position, where am I? The second piece, and so let's say we've got, that's our value right here, is this area to the left of it. So I want to know what that area is. Now the area under this entire curve is 1 or 100%. One good example of the normal curve is IQ. So IQ, everyone's going to have one. And it's going to go, it has a mean of 100, a standard deviation of 15. And so maybe I want to know, let's say this is 85. So what percentage of the population has an IQ less than 85? So to do that, the first thing I need to do is I need to convert that from an IQ score into a z-score. So I'm going to have z equals 85, which is my value, minus my mean, which is 100, and divided by your standard deviation, which is 15. Now keep in mind, I gave you that mean, I gave you that standard deviation. So this is going to work out to be negative 15 over 15, so a negative 1, and I'm going to write it as negative 1.00 because this is how my table works. So this is the first part, is I need to convert it into a z-score. So I have a z-score of negative 1.00. Now I need to go to the z-table. All right, so here we have our z-table, our standard normal distribution table. And you'll notice a couple things. So I have these numbers here on the left column and the top row. Those make up my z-score. Those are part of my z-score. So for instance, this right here goes with the z-score negative 2.93. It's in row negative 2.9 and it's in column 0.03. So for each of my z-scores, and let me change colors here real fast. I'm going to take that negative 1.00 and I'm going to break it right here. So I'm going to go to row negative 1.0 and column 0.00. If I had z equals positive 1.73, I'd go to row 1.7, column 0.03. And whatever's at that location, that is my area to the left. So let's go back to our table here, and we're looking for negative 1.00. So here's negative 1.0. That's this row right here. And column 0.00 is that first one. So this is my area to the left, 0.1587. So my area to the left of this is 0.1587. So I can interpret this as nearly 16% of my population is going to have an IQ less than 85. So our first part is getting that area to the left. If I wanted the area to the left of this z-score of 1.73, again, I'll go back to my table. So here is row 1.7, column 0.03. So where those meet up, that's right here at 0.9582. So the area to the left of z equals 1.73, whatever IQ that goes with, is 0.9582, or nearly 96%. So this is our first thing, is getting our area to the left. Now if we wanted to do area to the right, well, remember the whole area underneath that curve is 100%. So the area to the right is just going to be 1 minus 0.1587. So my area to the right is just the rest. If there's a 15% chance that it rains today, that means there's an 85% chance it won't rain today. So those are a large proportion of the problems. The other proportion is area in between. So again, I've got my normal curve, and for now I'm just going to put everything in terms of z-scores. I'm going to jump ahead to that part. If you're given these values in terms of an x, in terms of grams or meters or feet or whatever, the first thing I'm going to do is I'm going to convert it into a z-score. All right, so the third thing that I'd be interested in is area in between two z-scores. So let's say this z-score here and this z-score here. And I want to know what's this area right here. Well, what I can find this area right here. That's that area to the left of my bigger z-score. And then I can find this area right here, which represents the part of the green shaded there, or the green outlined, that I don't want. So what I would do is I would take the area to the left of here and subtract from it the area to the left here. So let's put some numbers here. So let's say this is positive 0.87 and this is negative 2.04. So for z equals positive 0.87, I'm going to go to row 0.8, column 0.007. So let's hop over here, row 0.8, column 0.07. That's right here. So that's 0.8078. So my area to the left of here is 0.8078. Now I need to find the area to the left of that negative 2.04. So I'm going to go to row negative 2.0, column 0.04. So this is again negative 2.04. So I can scroll that up a little more so we can see the top. Here's negative 2.0. Here's column 0.04. So where those come together is the area to the left is 0.0207. Make sure I wrote that down right. Yes. Okay. So this area here is 0.0207. So to get the area in between, I'm going to subtract. I'm going to subtract from the 0.8078, which is this bigger area, which includes everything I want plus some stuff I don't want. And I'm going to subtract away the part that I don't want. So 8078 minus 0.0207. Throw that into my calculator. This is the exciting part of the video while I type on my calculator. Is 0.7871. So that represents that red area. So this would be the area in between. Now if I wanted the area outside of, well, I do 100% or 1 minus the 0.7871. So that would give me the area that's not shaded, which would be, let's see here, let's do yellow. That would be that area there, and that area there is 1 minus 0.7871, which is 0.2129. So depending on which question you want, we've got two types of problems that are related. So the first one is area to the left, and the related one with that is area to the right. And they're related by just doing, if I find the area to the left, I do 100% or 1 minus. And then our second set of problems, area in between, I find the area to the left of both my z-scores, and I subtract big from little, because area always has to be a positive value, and so does probability. Now that brings us to interpretation of this, and our interpretation is any of these areas under here mean one of two things. Either this is the proportion of the population that has this attribute. So the proportion of the population that has an IQ between, and I'm making up numbers here, let's say 110 and 60. So that would be one interpretation. The second interpretation is, what's the probability that a randomly selected person would have an IQ in this range? So depending on how they word it, it's really the same problem, just two different interpretations. That's kind of the long and short of all our z-table stuff. So if you have any more questions, don't hesitate to give me a holler.